Now, what do you do in circumstances where you have three factors? In this case, we have x plus 3, x plus 5, and 3x minus 2. And the difference also between this and the previous problem is that we now have some sort of a quadratic on the top. Well, the basic idea is pretty much the same. We decompose this fraction into its three parts, but we're going to use constants a, b, and c. So here we've got a over x plus 3, b over x plus 5, and c over 3x minus 2, which will all sum together to equal our original, which was x squared plus 3x minus 44 over x plus 3 times x plus 5 times 3x minus 2. Now, if we take a look at this, in order to find a common denominator, what we need to do is we need to, for the fraction involving the a, multiply by the factors of x plus 5 and 3x minus 2, because those are the only remaining factors that aren't already part of the denominator of the a over x plus 3. Same thing for b. The b fraction already has x plus 5 in its denominator, and so we need to find a common denominator by multiplying b times 3x minus 2 and then times x plus 3. And same thing for c. That will be multiplied by x plus 3 and x plus 5. Just like in the previous problems, I've kind of skipped a step because we noticed that the denominator will just be x plus 3 times x plus 5 times 3x minus 2, which means we only need to be concerned about making the numerators equal. Just like before, we're going to use our method of plugging in the factors of each of the denominators. First factor we'll try is x is equal to negative 3, which will eliminate the b and the c terms. When we do that, we end up finding that negative 22a is equal to negative 44. And where we get the negative 44 from is by plugging negative 3 into the quadratic. After we do that, we can simplify and find that a is equal to 2. Our next factor is x is equal to negative 5. When we plug in negative 5, all of the a and the c portions cancel, which leaves us with just 34b is equal to negative 34, and b is equal to negative 1. Now the math is a little more complicated when we plug in 2/3, which is the x value where the denominator of the fraction with the c is equal to 0. And when we do that, we end up with 187 over 9 times c is equal to negative 374 over 9. There's all kinds of side work that you should be doing that for that to justify, and we eventually find out that c is equal to negative 2. So we rewrite our fraction as 2 over x plus 3, because a was equal to 2, minus 1 over x plus 5, minus 2 over 3x minus 2, just incorporating our a, b, and c values. When we integrate, we end up with 2 natural log of absolute value of x plus 3, minus natural log of x plus 5, minus 2/3 natural log of absolute value of 3x minus 2. The reason for the 2/3 is because of the inside function of the natural log, which is 3x minus 2. You can perform a substitution on this to figure out that we need to adjust by a factor of 1/3 in order to properly evaluate that integral. In combining this, we end up with natural log of absolute value of x plus 3 squared over x plus 5 times 3x minus 2 to the 2/3. The x plus 3 plus sign got smudged.